Let's work on solving systems of inequalities with graphing. Now, solving systems of inequalities with graphing is probably the most common way to do this. And this is an extension of a video I just shot about just graphing two variable inequalities. And there's going to be a three-step process here. The first step will be you simply graph the line, or in this case, lines, that you're working with, whether they're solid or dashed. The second thing that you're going to do is choose a test point not on the lines. There's going to usually be more than one line. Sometimes there might be two or more. And then shade the true stuff. That is not unlike what you're going to be doing here. So let's get started. I'm going to go ahead and graph this first one using red, and then I'll pick a different color for the second one. So graphing this, y is greater than 2x plus 3. Relying on some previous knowledge, I'm going to begin at my y-intercept and then follow the slope of 2 over 1. And I'm going to give myself some dots that follow that exact pattern. All right, there we go. I think about solid or dashed lines. That refers to this symbol right here. And since it does not have that extra little line at the bottom, if it had that line, I would make the line solid because it equals the line, but it doesn't. So I'm going to go ahead and dash this line. If you have a fancy tool, you can do it. I'm just going to dash it like that. Now, the final piece is I'm going to do the test point, but I'm not really going to do the test point yet. I could. Well, I guess I could do that. Let's go ahead and choose a test point. The test point simply has to not be on the line. So I'm going to choose a test point of 0, 0. It's really, really easy because it's not on the line. And to do a test point, a reminder, we simply put 0, 0 in the y and the x spot. So I'm going to just use Notability here. Put 0 in the y and 0 in the x. And let's see if this thing is true or false. So 0 is greater than 2 times 0 plus 3 is 3. 0 is greater than 3 is false. That means the test point is false. That means this entire side is true. So what I'm going to do is, before I even deal with the other inequality, I'm going to go ahead and I'm going to stick with red. I'm going to shade in red, or in this kind of faded red color, all of the stuff that would be considered true. If I had a bigger graph, I would have to shade more. So it's kind of like this, right up to that dashed line, and there we go. All right, now switch colors. I'll pick something that contrasts a little bit. We'll pick a blue, and we'll graph this second inequality. And I'm going to go right down through my steps again. Graph the line, solid or dashed. So this is y is less than or equal to negative or negative 1x. There's no y-intercept listed, so I know it goes through the origin. And it's negative 1, so I'm going to graph this way because I'm 1 up and 1 left, or if you like, 1 down and 1 right. And then when we decide solid or dashed, this one has the extra line below it, so that means that the line should be solid. So I'll just connect them up this way. There we go. Now I'm on the test points. Now notice how this blue line goes right through the origin. So I don't want to use the origin, but I'm going to use something else that's just not on the blue line. I'm going to choose another easy point, this one right here. I'm going to choose 0.11, which is also really easy to work with. And for number 1, 1, I'm going to go ahead and put that in for x and for y. So I'll remove the x and the y, put a 1 and 1 in. And then I try to find out, I don't have to do anything here, just find out if it's true or false. So 1 is less than or equal to negative 1. 1's less than negative 1. That's false. All right, so the test point, this spot right here, is false. That means this entire side of the blue line, that's all false. Even the stuff that's up in the red section, that's false for the blue one. It's good for the red one, but bad for the blue one. So I'm going to go ahead and shade the other way for blue. So in this case, I'm going to get rid of all these F's just to clean this up a little bit. And I'm going to shade, using blue, the other side. And I'll go right up to the line. And again, my line's not going to be the prettiest thing, and my shading won't be perfect, but you're going to get the idea. One thing that's nice about using a highlighter or some tool like this is that you will then be able to see where it overlaps, right? So you and I can both see that this region right here, that's the overlapped region. So what some teachers want is they want to see both colors overlapping. Other teachers would like to see, after you figure it all out, that you go back and you clean this up and only show off the section that should be overlapped, or we sometimes call it double overlapped. So if your teacher is like that, here's what they're going to want. They're going to want you to grab a color, and they probably won't care what, and they're going to go ask you to shade in only the region that solves both inequalities at the same time. So while I'm filling this in, every point in here satisfies or makes true both of the inequalities. So for example, just as a sample, if I grabbed this dot right here, just as a random place, this location is from the origin 1, 2, 3, 4, -5 and +1. -5 and +1 goes in both of the inequalities, and they would both be considered true. So, and any other point in here, including all of the stuff on this blue solid line, any point in here and to infinity in all these directions, those would all be solutions, right? That would be what we refer to as shade the true stuff, shade the solutions. So that is a very simple overview of how to solve systems.